Hey everyone, welcome to a lecture for 1.1. So we're going to go over definitions for our statistics course. And we're going to start with kind of the two halves that this course will cover. So the first part of this course is going to be about descriptive statistics, and the last half of the course will be about inferential statistics. So what are descriptive statistics? So the thing to notice here is that the root word is describe. So we're really just describing or summarizing data. And typically what we'll do is we'll take all of our data, we'll kind of put it nicely in a package or somehow kind of format it, display it visually. That usually comes out as maybe a pie chart, a bar chart, or a histogram. There are many other ways that you can show your summary findings, but these are kind of the most common ones, and we're going to cover all of this in chapter 2. So if you don't know what these things are, that's totally fine. That's why you're in this class. Inferential statistics, notice here that the root word is infer, which really means to kind of imply or generalize or deduce. So here what we're doing is we're making a conclusion or generalizations about a larger group based on a smaller group. And in chapter 8, we're going to see how to construct confidence intervals. And this is just one example of inferential statistics. And again, if you don't know what a confidence interval is, that's great because I'm hoping to explain that to you in chapter 8. So the big idea here is descriptive statistics is you have data, information, if you will, and you're just going to kind of summarize it, group it together, sort it out, parse it out, digest it, and present it. In inferential statistics, you're going to have some data. You're going to measure it, group it, whatever, look at it. But from that, you're going to make generalizations about a larger group. So let's look at two scenarios here. In the first scenario, we have the class average for Math 1342 last semester was 81.1%. So, the average was a B, a low B. And this was my highest scoring class. So here I'm not making any assumptions or generalizations or conclusions about a larger group that I haven't measured. I'm just looking at the data and comparing it to each other. So this is simply descriptive. In the second scenario, we have the class average for Math 1342 last semester was 81.1%. Okay. I conclude that this class, your class, will earn roughly the same class average. So now I'm kind of like predicting or making a generalization or conclusion about you, but I don't have your final grade information, right? I haven't measured anything about this particular group of students, your class. So this is going to be inferential. So in order to talk more about the difference between descriptive and inferential, we need to add some more terms to our vocabulary. So the first one is going to be individual. So the individual is really just the who. It's the person or object of interest. So in the case where I was talking about like the average grade for my 1342 class, my who was a student, a single student. And then the variable is going to be the what. Right? So what are we measuring about our individual? So in our example, if I'm looking at the final grade average class-wide, then the variable is the final grade of a single student. So right, so who am I measuring? A student. What is it that I'm measuring about them? Their final grade. So next I want to turn to population. So I want you to think about population as all, everyone. Or if you're not measuring people, you could think about it as everything. So this is just all the individuals of interest. For a sample, this is just going to be some. So this is just going to be a subset from the population. You can have good samples, you can have bad samples, you can have big samples, you can have small samples. And we'll talk about all those things as we get into sampling, bias, etc. But for now, just think about it as all, that's your population, and some, that is going to be your sample. So an example, not having to do with final grades from my 1342 class, completely different example. So maybe you could say you want maybe all US residents over 18. Right, so maybe you want to make some sort of classification, like maybe you want to talk about their income, maybe you want to talk about their height, their occupation, whatever, but you're interested in making a measurement on all US residents over 18. So if I wanted to sample that, well, that's a lot of people to sample. So I don't want to ask all US residents over 18. I don't even think I could if I wanted to. So a lot of the times what we'll do is we'll get a sample. And so you might do maybe, I don't know, maybe let's just like ask 10,000 US residents over 18. So you can see that it's just a subset of our population. So next we're going to talk about parameter and statistic. So parameter is associated with the population and the statistic is associated with the sample, but they're both measurements of the group. So this is just going to be a measurement or a quantity that describes the population. So maybe I would say, So maybe I would say something like 70% of all US registered voters actually voted in the 2020 presidential election. And so in this instance, 70% is the parameter, right? And so it is the number or quantity or measurement that describes the population. My population in this case is all US registered voters. So this is information that you can get, right? Because in the presidential election, they count all the votes. And we will not go into debate about that, but they counted all the votes. And so we know from record how many US registered voters there are. Like, we have that number. And from the actual presidential election, we know how many people voted. So we can say definitively that we have enough information to give the true parameter, the percentage of registered voters who actually voted in the 2020 presidential election. On the other hand, we could look at a statistic. And so this is really similar, except that it's a measurement for the sample. So for example, if we surveyed 100 registered voters, we surveyed 100 registered voters and found that 68.3% of them voted in the 2020 presidential election. So the big idea here is that if you have a good sample, then your statistic, which is your measurement based on the sample, if the sample is good, then your statistic should give you some indication about what the parameter is. Now, I just totally made up these numbers off the top of my head, but in general, you're not going to have the parameter, right? You're not going to have the resources to ask everybody to, in your population, and measure this thing, right? It's just going to be too cumbersome or logistically unfeasible. So what you do is you get a sample, something that's more manageable. Like, I do have the resources to ask 100 people, right? And so from that sample, you're going to be like, okay, well, if 68.3% of my sample voted in the election, I think my sample's good, whatever good means, which I promise, again, we will talk about what is a good sample and what is not. But if my sample is good, then this 68.3% is telling me something about the population. So I could infer from the sample that probably close to 68.3% of all US registered voters voted in the 2020 presidential election. And so that's kind of the idea of inferential statistics, is not having the true parameter, right? Not having the true number for my population, but getting a good sample, understanding what's going on within that sample, and then kind of inferring or concluding or generalizing from there that probably the same thing is going on for the entire population. So let us do a few examples here. We're just going to identify population, sample, parameter, and statistic. So here we have a large community college, has about 25,000 students, and we're going to do a study of 85 students from the college. And from that sample, we saw that 60 students out of those 85 had moderate or high math anxiety. So here, our population, right? So we want to know about math anxiety in all of our students at this community college. So it's going to be all 25,000. And our sample, because I don't want to ask 25,000 people the same question, I'm just going to sample the 85 students. And these are the students in the survey. So my parameter would be the total number of people right out of the 25,000 with math anxiety. Well, I didn't ask those 25,000 people, but that is the thing that I'm after. I'd like to say, maybe 10,000 people, or, maybe a proportion, maybe a percentage, right? But I don't have that information. So I go to my sample and I get my statistic, which was that 60 out of 85 have math anxiety. And so hopefully if my sample is good, then that 60 out of 85 as a proportion will translate nicely into the actual proportion of the population. Right, so what makes a good sample? What maybe things to avoid as well we can talk about. So here we have a definition for a representative sample. So in the definition, a representative sample has characteristics, behaviors, and attitudes similar to the population from which the sample is selected. So basically what you're saying is you've got a population of people, it's huge. You're not going to be able to ask, survey, poll, etc., all of them. So you just want to grab kind of like a small subset, but you want to make sure that that smaller subset, that smaller group, that sample looks like, sounds like, feels like, thinks like the entire population. If you don't have that in your sample, then your sample is not representative and it's biased. So here's an example of a biased sample, or something that's not a good sample, something that's not representative. So let's say you were to poll let's say you pull 85 students from honors math classes at that college. Well, I don't think that's a representative sample because most students at this college aren't in your honors math classes. Moreover, those people in that honors math classes likely suffer less from math anxiety. They probably have a lot of confidence. They've done well historically. They're continuing to do well. And they're less likely to be hindered by math anxiety issues. So this is a biased sample. So here's another one. So how about we poll '85 students, but they all work full time. This is not a good sample either because it's not the case that 100% of the students at this college work full time. So since not all 25,000 students at the college work full time, your sample shouldn't be composed of 85 students that all work full time. It should have a mix of people who work full time, part time. It should mimic what the population actually is. All right, so let's go ahead and look at this next example. So now we're going to go ahead and add an individual and variable. So example 111, in 2010, the Pew Research Center questioned 1,500 adults in the US to estimate the proportion of the population favoring marijuana use for medical purposes. It was found that 73% are in favor of using marijuana for medical purposes. And so now we want to state the individual, the variable, the population, and the sample. Right, so let's go through the question and kind of pick out things. So to begin, we have that the Pew Research Center questioned 1,500 adults, right? So we questioned 1,500 adults. So these 1,500 adults, these are the people in our survey. So our sample is actually the 1,500 adults surveyed, and it's going to be 1,500 because you're asking them a yes or no question, right? Are you in favor of using marijuana for medical purposes, yes or no? So it's going to be 1,500 responses that are either yes or no. So, I'm asking 1,500 adults, but look at this next part. Trying to estimate the proportion for the population favoring marijuana use for medical purposes. So these 1,500 are my sample. What's my population? So again, we're using it to estimate the proportion of the population. So for us, our population is going to be all US adults. Or you might think of that as everyone's response to the question, right? Do you favor it, yes or no? So then the next thing you want to do, now we have this 73%. So this isn't actually stated in the question, but this 73%, I'll just go for it anyway. So that 73% is actually a measurement on the sample. So that's going to go with statistic, right? So that was that 73%. The proportion of the sample, the measurement of the sample, the quantity for the sample, that's your statistic. So statistic goes with sample, parameter goes with population. So the statistic is 73% are in favor. For the parameter, again, we didn't ask all US adults because we can't and we don't want to, is the true proportion in favor of using marijuana for medical purposes. So the last thing you want to do is state the individual and the variable. So remember that the individual is the who and the variable is the what. So for individual, this is just US adults. So a US adult, one of them is an individual, and the variable, so what are we trying to measure? Just answer you ask them the question, what are we asking them? What are we measuring? We're measuring whether they are in favor, yes, of using marijuana for medical purposes, or are they not? No. All right, and so for our last example here, we've got a scenario and then we've got some multiple choice. So we're going to be asked to identify sample, statistic, population, variable, parameter, individual. So we wish to estimate the mean cholesterol levels of a patient. So just really briefly, when we say mean, I want you to think, so colloquially, we call this average, but as we dive further into our descriptive statistics, we're going to kind of firm up this terminology. So we're going to use words like mean or median. Both are synonymous with average. So just for now, replace that word with average and we'll kind of get down to splitting hairs later on. So we wish to estimate the mean cholesterol levels of a patient 2 days after they had a heart attack. And to estimate the mean, we collect data from 28 heart patients. So how can we determine what is a sample, statistic, population, variable, parameter, who's the individual, et cetera. So let's start with the individual, the who. So who are we asking? Who are we trying to observe? So we want to, excuse me. Let's look at our list actually. So which one is most like a who? Cholesterol level? No. Mean cholesterol? No. Okay, so we have C. And that's probably the only one, right? So this is the only one that's a who, a heart patient 2 days after they had a heart attack. Okay, so this is going to be our individual. Who are we measuring or observing? Heart patients or a heart patient 2 days after they've had a heart attack. So we've got our individual. All right, let's see if we can figure out sample. So our sample is coming from 28 heart patients. So is our sample 28 heart patients? Kind of. So it's the blank of 28 heart patients. What is it? It's going to be the cholesterol of 28 heart patients. And you're going to take those 28 heart patients and you're going to kind of digest that information. So you want to take the set of cholesterol levels of 28 heart patients 2 days after they had a heart attack. So this here is going to be your sample. All right, so what do you do with this set of cholesterol levels? You have 28 heart patients 2 days after they've had a heart attack, and now you've gone through and you've recorded their cholesterol levels for all 28 of those people. And so what we want to do is we're looking at the mean or the average of those 28 measurements of cholesterol. So when we make a measurement on the sample, then that's going to be our statistic. So we need to find the mean cholesterol level of 28 heart patients 2 days after they've had a heart attack. And so that's going to be B. This is our statistic. All right, so we've got a few things left. We've got A, cholesterol level. We've got D, set of cholesterol levels of all heart patients 2 days after they had a heart attack. I'm seeing a key word in there. I'm going to highlight some keywords really quickly. There's 2 times I see all. So let's see if we can kind of parse out how those are different. In D, it says the set of all cholesterol levels of all heart patients. In E, it says the mean cholesterol level of all heart patients. So in D, we have a list of cholesterol levels of all these heart patients, right? And in E, you take that list and you take the average or the mean of those things. So D is going to be our population, and then E is going to be our parameter. So for population, it should be D. And for our parameter, it should be E. And so by process of elimination, you could deduce what is the variable. But just to be clear, the variable, remember, is the what. What are we measuring? The individual is the who, the variable is the what. So we know our who is individuals 2 days after they've had a heart attack, and then you measure their cholesterol. The variables, what is it that you're measuring about them? Well, we're measuring the cholesterol levels. So this is going to be your variable. And so this leaves us here with A.